All right. Hi, everybody. This video is for my Algebra 1 class. We're starting our Chapter 3 test review. I'm going to work through the front and back of the first page today, and then we'll finish the second page tomorrow. So make sure you have your Chapter 3 test review and your book with you. We'll go through some definitions that you need to make sure you are familiar with and understand. And then we're also going to go through some various problems. First off, let me get my computer down. I'm going to work it through it on the Word document, so hopefully it will behave. But first, the first three sections of Chapter 3, we have some terms and definitions that we need to make sure we're familiar with. The first off is, what do we call an equation that contains two or more variables? And hopefully you've gone through this beforehand and looked through your book and tried to figure out what you can. If you haven't, I strongly suggest you pause this and go back. Do the best you can, see what you can gather on your own, and then check your answers here. But I'm going to go ahead and start off going through it. So an equation that contains two or more variables, hopefully you remember, is what we call a linear equation. Cannot talk and write at the same time, so I'm not even going to try. This is a lot of your physics or laws of motion, equations, Pythagorean theorem, and all of its various forms. And so you remember, and we'll do some practice, where you have multiple variables and you're having to solve for one particular variable. So you're modifying the equation to set it up so that you can plug in your known variable values and solve for your unknown. And when you have that, when it's a linear equation, you must have two or more variables, two or more unknown. And in many cases, when we practiced this, we had like the whole equation was all variables. Okay, but you need to know that definition. Okay, what do we call comparison of two numbers by division? It's usually represented as a fraction. This is what we call a ratio. You also will have it divided by a colon, but that's ratio. Okay. And then what do we call rates that have different expressions representing the same quantity in the numerator and the denominator? These are what we use to convert rates with different units. So when you go from miles per hour to feet per second, or when you go from the, what do we call it? Imperial system to the metric system, the conversion rates between like an inch and a centimeter and that kind of thing. So these are called unit multipliers. They are what we use to convert different units or rates to different units. So unit multiplier. And we'll get a little bit of practice using those again. What do we call a statement of equality between two ratios? Hopefully you remember this. I think it's section 3.2, but this is when we worked with proportions. So this is a proportion. Again, this will apply to some of the problems we're going to work on later. And then what if two figures have the same shape, but not necessarily the same size? We call these similar figures, as opposed to congruent figures, which you'll learn more about in geometry next year. These are similar. And then, of course, an example of that, so a shape that will always be similar is a square. And a square is really the only, well, there's also a circle, but like triangles can always have different angles. So they would not be similar because those angles can be very, very different. All right, and then of course, by definition, polygon, in which the corresponding angles are congruent, which means the angle values are the same and the sides are proportional, those are called similar polygons. But they must have the same corresponding angle measurements in order to be considered similar. Okay, so let's get into some practice. These are the first two are examples solving for linear equations, solving for a particular variable. So in the first one, we have a numerator of 4x minus 2 divided by 2x plus 2y. The number one thing to remember, guys, when you are trying to solve these for a particular variable is you have implied parentheses here. So when you do your inverse operations, remember that before you do multiplication or division, you must, what am I trying to say? No, we're doing inverse operations. So before you do your parentheses, you must do your multiplication division. Before you do multiplication, you must do addition and subtraction, etc. But you need to remember that those are understood parentheses there. So they're the last thing that you're going to solve when you're doing an equation, because we use reverse order of operation. So with that said, let me show you what I'm talking about here. So you have 4x minus 2y divided by 2x plus 2y equals 3. And we're being asked to solve for x. That's what we're trying to get on the left side and everything else on the right. So because that 2x plus 2y in the denominator is a parentheses, what we need to do is we need to do the inverse operation of division to get rid of that on the left side. So we're actually, of course, the inverse operation of division is multiplication. So you divide both sides by the whole expression, 2x plus 2y. If you divide it on one side, you divide it on the other. All right, and then these cancel each other out, and you're left on the left with 4x minus 2y equals 3 times 2x plus 2y. All right, we've gotten rid of that fraction. This is much less intimidating, hopefully. The first thing you should see you need to do is we need to distribute on that right side to distribute the 3 into the 2x plus 2y. So remember, you multiply it by both when you get rid of those parentheses. So this becomes 4x minus 2y equals 3 times 2 is 6x plus 3 times 2 is 6y. All right, now we're starting to look a little bit more familiar. We are simplified on both sides. Guys, make sure you keep this as neat as possible on your notes so you know where you're going with this. I'm going to go ahead and move back up and use my empty space here on the right. So let me repeat that. I have 4x minus 2y equals 6x plus 6y. All right, so again, because I'm solving for x, what I want to do is I want to get this entire little expression here, 6x, on the left side. And then I need to move the 6y over. So I'm going to go ahead and move that first. So I'm going to subtract 6x from both sides. Remember to carry the variable. And 4 minus 6 is negative 2x minus 2y equals, that's been canceled out, 6y. Now I can move my negative 2y to the right side of my equal sign. So we add 2y to both sides. Remember to carry the whole expression. And so we're left on the left side with negative 2x equals 6 plus 2, so 8y. All right, so now all we have to do is we need to divide both sides by negative 2, and that isolates the x on the left side. So negative 2, so x equals, now negative 2, we know our answer is going to be negative because we have a negative only in the denominator. 2 divides into 8 4 times, and then of course the y is left. So our answer is x equals negative 4y. Whoa, sorry. X equals negative 4y. That's a lot simpler than that crazy equation we started with. Okay. If you have any questions about that, if you feel like that's something you could not do on your own, then just put a little star by it. We need to work on that a little bit more. Or go back and now that you've worked through it one time, put that original equation back on a separate sheet of paper and put this aside and see if you can work on it again, like we just did, on your own without any sort of reference. That's always a good way to practice these math problems as well if you're struggling. Okay, so number 9, we have m equals a plus b divided by 2, and we need to solve it for a. So again, anytime that you have an expression in a numerator, you need to treat that like it's in parentheses. That's understood parentheses there. So when you are isolating the a, also, this is just me, so I'm sorry if this really confuses anybody, but because I'm solving for a lot of times I like to reverse that. So I would put the a plus b divided by 2 on the left side and the m on the right. But I'm not going to do that because I don't want to confuse anybody. But that way, when you're done, you have your a on the left and your answer on the right. Okay. Anyway, so the first thing we need to do here is we need to divide both sides by 2. Because reverse order of operation tells us we need to do our division before we get rid of our parentheses. So what this does is this gets rid of it on the right, and we end up with 2m equals a plus b. This one's a little simpler, I think. So then if we're solving for a, we need to get rid of that plus b. So we subtract b from both sides. I know this looks a little bit weird, but I'm going to put it here. Negative b plus 2m. I don't know, that's weird. But I would put that as 2m minus b. You could also do it like this, minus b. Just no, you've got to write that out long ways. And that equals a. So that's it. We have a on one side and we have the rest of our expression on the other side. So when you write this on the line, it's a equals 2m minus b. Okay. So 10 and 11 talk about proportions, ratio and proportion. So we're going to do these two based on the notes for section 3.2 if you want to reference those. So remember, whenever you're looking at two fractions on opposite sides of an equal sign, you are looking at an equation that you can cross multiply across the equal sign. So that's what I'm going to do here. I'm going to cross multiply. So I end up on one side with 6 times x plus 3 equals 4 times x plus 8. All right. And then hopefully you remember the next step we need to do is we need to distribute. So remember, when we distribute, that 6 gets distributed into both. If you end up with negatives, be careful to continue the negative. We'll have some practice with that in the next one. All right, so 6 times x is just 6x. 6 times 3 is 18. 4 times x is 4x. 4 times a positive 8 is positive 32. All right, so now let's get all of our x terms on the left side, our constants on the right, and then we can solve for x. So I'm going to subtract this. Why did I do that? Hold on. I'm going to subtract 4x from both sides. That gives me 2x plus 18 equals 32. Then I subtract that 18 to get rid of it. And I'm left with 2x equals 32 minus 18, which is 14. Yeah, all right. And then I've run out of room. So I'll move over here, 2x equals 14. We should hopefully know we just need to divide by 2, and we end up with x equals 7. Now, if you are not sure you have done something right, take that value you solved for x, plug it back into your original equation. If you look back up right up here by the number 10, then you see 7 plus 3 is 10. 10 over 4 simplifies to 5 over 2. And then plug in the 7 for the x on the right side, and 7 plus 8 is 15. 15 over 6 also simplifies to 5 over 2 because 3 divides evenly into both. So you end up with 5 over 2 equals 5 over 2, and that's a true statement. So we know we're right, x equals 7. All right, so number 11, we have 2p minus 3 over 6 equals 3p plus 3 over 4. So again, just cross multiply. 4 times 2p minus 3 equals 6 times 3p plus 3. Okay, so 4 times 2p distributes into 8p. 4 times -3 is a -12. 6 times 3p is 18p. And 6 times 3 is 18. So that stays the same. Okay. All right. So we need to get both of our both of our terms with variables to the left side of the equation. So I'm going to subtract 18p from both sides. So that becomes 0. So this just becomes 18. That's this guy. And then 8 minus 18 is -10p. So -10p minus 12 equals 18. So now we have to get rid of that minus 12. So we add 12 to both sides. And we end up with -10p equals what, 30? Yeah, 30. All right, so then divide both sides by -10. At this point, we're old hat. And p equals -3. Okay. All right, so let's look at some more conversions. So again, this is where we use those unit multipliers. So if you need to jot those down on the side, for example, we're converting from miles per hour to feet per second. To me, the most complicated of these two is the miles to feet. You need to know that 1 mile equals 5,280 feet. And then of course we know that 1 hour, that's a mile, 1 hour equals 60 minutes. And 1 minute equals 60 seconds. All right, so this gives us conversions from miles to feet and from hours to seconds. I'll show you how to use those. All right, so let's start off with our first rate here. That's 60 miles per 1 hour. Now, if we want, first, let's go ahead and convert the miles to feet. And if you have, remember, if you have the same thing in your numerator and denominator, you can sort of treat your units like variables and just cancel them out. So use your unit multiplier that 1 mile equals 5,280 feet. And you can see that those miles cancel out. I have now, if I multiplied all this up, I would have calculated feet per hour. Okay, based on our original rate. But I need feet per second. So I need to add some more unit multipliers here. So this is just how I've always done it. So again, just put a note by here if you get totally confused by what I've done. So I've got my feet in the numerator, which is what I want, right? I need feet in the numerator, seconds in the denominator. So let's convert this hour to seconds. So hour starts off in the denominator. So I'm going to put it in the numerator for my unit multiplier. 1 hour equals 60 minutes. So that means that my hours are going to cancel out. And then 1 minute equals 60 seconds. So you see how now I've ended up and I have feet in my numerator and I have seconds in my denominator. So once I multiply all these up, all my numerators and then all my denominators, I'm going to end up with a rate that gives me feet per second that is the exact same rate of speed as 60 miles per hour. All right, so let's take our actual numbers. I mean, we're not going to count 1, right? Because anything multiplied by 1 is 1. So let's look at our numerator first. Our numerator is 60 times 5,280. So I'm going to take my 60 times 5,280 feet. And then let's look at our denominator. We have 1 hour times 1, which is 1. And then we have 60. So we have 60 minutes, which we canceled out. And then we have 60 seconds. So 60 times 60 will give us our denominator. All right, well, when you do it this way, you can also see that that original speed of 60 miles per hour, in this case, 60 divided by 60 is going to be 1. So we can just cancel that out and we end up with 5,280 divided by 60. Let's plug that. If you plug that into a calculator, then you find that 5,280 feet in 60 divided by 60 gives you 88 feet per second. And that is your answer. which is kind of cool. If you're driving along and you're going 60 miles an hour, then just know that every second you are moving 88 feet. All right. Now we have a metric one just because metric is nice and easy and fun. And so we want to convert 100 meters per second to kilometers per hour. Sort of the opposite of what we just did. We're going from a small distance in a small period of time to a larger distance in a larger period of time. So let's look first at our unit multipliers. So first, if we're going from meters to kilometers, then we know that 1,000 meters exists in 1 kilometer. Hopefully you remember those from arithmetic. And that's pretty much all we need in our numerator, meters to kilometers. So we have one unit multiplier for that. If we go from seconds to hours, we have 2. So we know that 60 seconds equals 1 minute. And we know that 60 minutes equals 1 hour. So we have all of our unit multipliers here. So let's start with our rate of speed, which is 100 meters per second. And first, let's go ahead and convert that to kilometers. So we know that 1 kilometer is going to be 1,000 meters. And so we know you've got that set up right because your meter units cancel each other out. All right, so next, let's get rid of the seconds in the denominator. We need to change it to hour. So we know that 60 seconds is 1 minute. And then we know that 60 minutes is the same as 1 hour. And then that's good. Let's see, that cancels out our seconds, it cancels out our minutes, and we end up with kilometers in the numerator and hour in the denominator, which is the rate we are looking for. So we're good. So we know 100 times 1 is just 100. So we can eliminate all of your ones and let's simplify. So 100 times 60 times 60 divided by, looks like just 1,000, right? We've got a 1 here and a 1 a minute, 1 an hour. All right, so when you do 100 times 60, just add up your zeros. You have 1 in 60, you have another 1 in 60, so that's 2, and then you have 2 in 100. So it's 1, 2, 3, 4 zeros, and then 6 times 6 is 36. So that's our numerator, 360,000 divided by 1,000. Well, these guys just cancel each other out. We know that 10 divided by 10 is 1. All right, and so you're left with 360 kilometers per hour. Now, if you really want to see how fast that is, you can convert that to kilometers per hour to miles per hour, which is not a simple conversion, but you'll find that still really fast. Maybe not NASCAR fast, but close to NASCAR fast, I think. Anyway, so that's your answer there, 360 kilometers per hour. Maybe on the Autobahn. Autobahn. Okay. Let's see. All right, so page 2. This is the second page of your test 3 review. We're looking at some more unit rates in word problem form. So state the unit rate if it costs $27.50 for 11 gallons of gas. So pretty much all you're doing is you're setting up your known rate and then you're equaling it. So let me just show you. $27.50. So it's $27.50 for 11 gallons of gas. So this is dollar gallon equals how much money for 1 gallon. This is your unit multiplier. So unit multiplier has it usually has like a 1 either in the denominator or the numerator, but we're looking for the ratio between these two. So we're asking if we fill up a whole tank with gas and it's $27.50, how much are we paying per gallon? So When you have it set up like this, all you need to do is cross multiply to determine these unit rates. So that means that 11x equals, and then 2750 times 1 is just 2750. So equals 2750. So that's pretty simple. Divide both sides by 11. When you plug that into a calculator, you discover that x equals $2.50 per gallon. That is your rate. That's money or dollar per gallon. So $2.50 per gallon. Easy enough, I hope. Let's look for, I think you have a couple of these on your test, so I gave you a few different examples. So Addison drove 960 miles in 16 hours. What was her speed in miles per hour? We're going to assume we're just calculating her average speed. So we have a rate of 960 miles per hour. Excuse me, per 16 hours. Ooh, that'd be crazy, right? Equals how many miles in 1 hour? So in 1 unit of time, 1 unit of hour, how many miles did she drive? That's what we're setting up here. I'm going to ask for those unit rates. So cross multiply 16 times x equals 960 times 1, which is just 960. And then you can plug it into your calculator and you find that 16 divides into 960 60 times. So her average speed was 60 miles per hour. Okay. All right, so 16, this is really nice. Like I always try to drive in a way that gets me the most efficient miles per gallon. So I kind of like this one, but it's asking what is the unit rate if a truck uses 85 gallons of diesel for a 1,530 mile trip. So it's asking how many miles per gallon is he getting here? So I would put the 1530 miles were driven in with on 85 gallons of diesel. And so I need to know how many miles did he go on 1 gallon of diesel? Gal. Okay, so then cross multiply and you end up with 85x equals 1,530. Right, and so then you just divide both sides by 85 and you discover that he is getting 18 miles per gallon. I don't know how good that is for diesel. I'd figure it's probably pretty good. I don't know. Okay. All right. So let's look at these scale and model questions from section 3.3. So if you remember when we looked at similar figures, in this case, we have some rectangular cubes that are similarly proportioned, but you can see obviously one is larger than the other. So we need to find out what their proportions are compared to each other. So in the case of finding just one side, we have two sides to compare for the smaller one, and we have one side for the larger one, and then we're being asked to find the corresponding side, that base side. So we would set this up like a proportion. So 4, or like a ratio, excuse me. So the ratio of 4 to 12 is the same as the ratio from x to 15. And then again, you have fractions here. We just cross multiply. And we end up with 12x equals 4 times 15, which is 60. That should be an easy multiplication for you. If you've memorized your tables, you know that 12 goes into 65 times. So this base here is 5. All right, so for the second one, it's asking us to find the area. It says the top of the larger figure has an area of 100 units squared. Now remember, whenever you deal with area, it's squared. So you have to remember that. It's one side times another side. So if your units are squared, when you're determining proportion, you need to make sure if you're using a line segment to set up a proportion to an area, you need to square your line segments to get your answer right. Let me show you what I'm talking about. So what is the area of the smaller figure? We want to know what this guy is right here. So now that we've determined the proportion between the smaller figure and the larger figure, we know that 4 is proportional to 5. Why did I make that so big? I need that room. Hold on. 4 is proportional to 5 squared as, let's see, 4 is our smaller one, so that's my numerator, as x is to 100. And that's, again, that's because you're taking a side line segment proportional to another. Because you're taking those corresponding sides, you have to make sure you square them in order to find their proportion to the area of a full side of the figure. So then you just square it. For anybody that needs it, you can rewrite this as 4 squared over 5 squared equals x over 100. All right, so 4 times 4 is 16. 5 times 5 is 25. So 16 over 25 equals x over 100. Then you can just cross multiply. I'm going to keep using my space over here. So 25x equals 16 times 100, which is 1600. Okay, so then simple math. We just divide both sides by 25, not 22. And x equals, I think, 64. Yeah, you plug that in your calculator. You find that x equals 64 units squared, whatever our unit is. So x equals 64. Okay. So let's look at volume. Okay, so volume is actually talking about the whole volume of the figure. So the units for volume are always cubed because it's length times height times width. So it's unit times unit times unit, which is cubed, definition of cube. So if the volume of the smaller figure is 192 units cubed, what is the volume of the larger figure? All right, same thing. So pick two sides, two line segments here. So I'm going to pick the proportion between 4 and 5, like we did last time. Get small numbers. Lord have mercy. Start cubing stuff and numbers get huge. Okay, so 4/5 cubed equals 192 is our smaller figure, and we're trying to determine our larger one. So it's 192 over x. So 4 times 4 times 4 is 64. 5 times 5 times 5 is 25 times 5, which is 125. And then this stays the same, 192 over x. All right, so let's cross multiply. 64x equals 125 times 192, which equals, I think, 24,000. 24,000. Plug that in your calculator and you get 24,000. Okay, so now we just divide both sides by 64. And you will find that that equals 375 units cubed. All right, if you are not sure that your answer is correct, think about this logically. So use your figure. I say this one is 375 units cubed. The smaller figure is always going to have smaller areas and smaller volumes, right? So if you calculated it and maybe you got your fractions upside down or are not set proportionally, then you're going to get a weird answer. So you would know that the volume of the smaller figure, if it's 192, it makes sense that it's going to be significantly bigger, but not like thousands bigger. So 375 is proportional. If you know that the area of the larger one is 100, then the area of the smaller one should be smaller. So 64 makes sense. So just look at those and you'll know that you've done it correctly. So in this case, x equals 375. All right, I'm actually going to stop there. I'll do the last one tomorrow because it sort of corresponds with the other problems on the next page. And we are done. So hopefully that made sense to you guys. If not, please put a star or a note, or question mark or something by the problem you're confused about. And we will talk about it more in depth. Obviously, I'm not going to try to do virtual test review and then have you come and immediately take the test in class. I'm going to leave a Q&A day for us to just review some extra stuff if you need it, and then we'll take the test. But otherwise, please do your best. Try to understand it. Get all your notes organized because you will have them available. And hopefully I'll see you soon. Bye, guys.